Okay, well, one of the things that I said just a few minutes ago, lots of classes in the past I find they really love this unit because I don't know they're into gambling, but it doesn't just have to be gambling. It can be sports, for example. There's a lot of statistics in sports. I think I asked this question before. Did anybody ever watch the movie Moneyball?
Yeah.
You've seen that movie before? It's about Billy Beane and the Oakland Athletics and how Oakland is a very poor market. They don't have a lot of money. And so they were trying to build the best baseball team they could. And essentially it came down to stats. They were trying to look at percentages and probabilities and figure out how to build the most efficient team for how much money it cost. For example, you could go out and pay, I don't know if you're a sports fan, the Blue Jays were really good last year. The Blue Jays had a guy named David Price on their team. Great pitcher. But he went to Boston this last year because Boston offered him like $30 million a year. Now, don't get me wrong. David Price makes any team he's on better. But now you got to start weighing, what's the percentage that he is worth compared to a cheaper option, for how much wins he's going to provide for your team. Does that make sense? And the Blue Jays decided to pay a different guy about $10 million instead, and hopefully they can spend the other money on something else and be a better team in the long run. Anyways, statistics and probabilities, like sports, are great for that. And so I found an example here to kind of introduce odds that matters to me, at least. So I don't know if any of you guys have ever wondered about this, but you ever see like gambling lines for sports events and wonder how they work? Or just never come up in your life before? Like here, I pulled this off of the Super Bowl for next year. So if you don't know, my team's the Patriots. So they're most likely to win. They're ranked number 1. Currently, or at least when I made this slide here, they were getting 8-1 odds. Anybody ever heard that before, that phrasing? I'll give you 8-1.
Well,
You know what that means?
is there 1 in a chance?
Not quite. It's close. It's actually a 1 in 9 chance. Okay? The way odds work is the two numbers. The first number is the odds of either winning or losing, and then the second number is the opposite of that. So if I were to give you 8-1 odds, the way this works is they think the Patriots will lose the Super Bowl 8 times and win it once. So as a percentage, Vegas gives them a 1 in 9 chance of winning. Does that make sense? So like 8 times they're going to lose, 1 time they're going to win. So their percentage of winning would be 1 in 9. 10-1 odds means they think they're going to win 1 out of every 11 times. So 1 time they win, 10 times they lose. Right? If you go down here to the very bottom, I don't know who the worst team in the league is. I think it was Miami. Miami was getting like 300-1 odds. That means that they figure if you played the Super Bowl 301 times, they'd win 1 of them. Does that make sense? So your odds aren't really all that good. So what I wanted to do is talk about the gambling overlays then of how this works. The way Vegas is going to pay you right now, if you were to wager $100, like let's say you wagered $100, Vegas would pay you $800 if you won. If you don't win, they take your money. Does that make sense? So that's where this plus 800 comes from. Basically, this is how much money they'll pay you on $100. So you can see, like the Patriots, if I invest $100, I get back $800. If I invest $100 on the Texans, I get back $3,000. So the bigger the odds, the bigger the payoff. But it also is pretty unlikely that you're going to win. Does that make sense? So, on the next slide here, I actually pulled up the official gambling website just to show you in a little more detail in case you cared. Maybe you don't care. I don't know. So since I pulled up the slide, the odds are actually a little bit lower. The Patriots are now plus 600. What does that mean their odds are?
1 out of 7.
1 out of 7, basically. Now, the way we'd phrase that is the odds would be 6-1, and the probability would be 1 out of 7. Okay. I need to really focus on the language they're going to use on the diploma. Odds is always written as a something to something, right? Like you'll see it written as a, where's that slide? You'll either see it written as a 7-1, or you'll say like 7-1 odds. Those are odds. If you were to say 1 out of 8, that's a probability. So that's a probability. These guys are odds. Does that make sense? So where's that website again here? Just do some cursory gambling here. I won't actually bet, obviously. So, okay, who else follows football? Anybody? Nobody else. Okay, who would you cheer for?
I've always cheered for Denver.
Okay, let's do Denver then. So currently Denver is... Goodness, where are they? Here they are. Super Bowl champions. They're actually way at the back here. They're plus 1,600. So let's say we wanted to make a bet on Denver. Why is this not working here? Denver. Oh, this thing isn't working the way it was. Give me a second. Oh, this thing was able to show me how much money you'd make yesterday. Let me try that one more time. If not, we'll move on. Okay. Oh, shoot. Okay. I was supposed to pull up a website here that was going to show you how much money you'd win based on your bet. So I guess I can't show you the website, but we could talk through it. If Denver is plus 1,600, what that means is they're giving them 16 to 1 odds. So let's say that Shody was going to gamble amount of money. Shody, you want to wager $1? How much would you win if they won? Do you know? If you gambled $1, how much would they give you back?
If they won.
If they won. With these odds here. 16 to 1 odds.
$700.
16 to 1 means if you wager $1, they'll give you 16. Does that make sense? So if you wager $10, they'll give you 160.
You wager $100, they give you 1,600.
Which is where that number comes from. All these numbers right here are based on a standard $100 bet. So like if you really want to go crazy, bet on the Dolphins. If I were to wager $100 on the Dolphins, I'd get back 6,600. That being said, this is how Vegas makes money. Only one team wins, right? So they have to pay some people back, but all the rest of the money they take for themselves. Does that make sense? Let me try my next slide here. We'll move on. Anybody, I'm gathering here you guys aren't the biggest gambling crew, so this doesn't work as well. But has anybody ever heard of a craps table?
What?
A craps table. Anybody know what that is? So it's like, maybe you've seen this in the, I don't know, popular media before. It's where you go to the table and you blow on the dice, lucky 7, you roll the dice, and you're hoping to get a certain number. Okay. I want to show you how Vegas works here. Vegas, if you get something called craps on a craps table is either you roll a 2, a 3, or a 12. And if you win on one of those ones, they'll give you $8 back for every $1 you invest. So if I put up $1, I'll get back my $1 plus 8 more. Does that make sense? Or here, if I'm going for 7s, if I pay my $1, they're going to give me back 6. They're going to give me back my $1 plus 5 more.
So every time you win, you get $6.
Yeah, but technically you only get 5 though because you already paid your $1, right?
Yeah.
So if this really tells you what your winnings happens to be. So they'll pay you like here aces or boxcars. They'll pay you 30 to 1. Right? But that being said, how hard is it to roll a 2 or a 12? That's not all that easy to do, is it? So what I wanted to do here is talk about how these odds for payoff works versus the probability of them occurring. When you're rolling 2 dice, how many ways are there to roll 2 dice?
One way.
How many ways is there to roll 1 dice? 6 ways. 1 through 6, right?
Oh, I see.
Does that make sense? So how many ways is there to roll 2 dice?
Oh, well. More than that, so it's 6 times 2.
36 is right. Because there's 6 ways to roll dice number 1. There's 6 ways to roll dice number 2. And you're rolling both of them. So there's 36 ways to roll these dice. I'm going to make a sample space real quick here and just write out all the possibilities for you. Maybe you want to do this below. So I'm going to make a grid. You can do 1, 2, 3, 4, 5, and 6. And then 1, 2, 3, 4, 5, and 6 here. And I'm just going to add up what they add to in the middle here and see what number you get on a dice. Okay, so if you get double ones, what does it add up to?
2.
Okay, you guys can probably do this without me saying it all. So like 1 and 2 will add up to 3, 4, 5, 6, 7. 3. Okay, so I think I've made my sample space here. I'll just put a solid line in between it so that we know this is 1 and 2 different dice we're rolling. What's the most common number to roll on a dice? With two dice collectively. And the answer is 7, yeah. 7's come up a lot. So why don't we try that example here? Any 7. The way Vegas works is that if you roll a 7, they pay you money, right? If you invest $1, they give you 5 back. Well, let's talk about how this is why Vegas makes money. I'll show you why. They're going to pay you $5 for every 1 that you invest. Basically, they think that you're going to win every 1 out of 6. Does that make sense? Well, now let's do the probability here. How many 7s are there on here? 1, 2, 3, 4, 5, 6. So you can win 6 times. How many total possibilities were there, though? 36, which is actually 1 out of 6. So Vegas is actually paying basically exactly the same here. They're giving you 5 to 1 because they think your percentage is 1 out of 6 and your percentage is 1 out of 6. So that's why they pay that way. Does that make sense? Let's try craps. So craps is pay off 8 to 1. They think that you're going to win 1 out of 9. Let's check and see if that makes sense. A 2, a 3, or a 12. Here's a 2. Here's a 3. Here's a 12. There's a 2, there's a 3, there's a 12. So how many do we win with? We win with 4 out of 36. Which, by the way, reduces down to 1 out of 9. That's actually where they get their payoff from. Is 1 time out of 9 they think you're going to win. But here's where they make their money. Ace deuce. Let's say you go for this one here. They're going to pay you 16 to 1. Ah, that sounds fantastic. 16 to 1, right? Which means what do they think you're going to win? 1 out of every 17. Okay, well, how many 3s were there, though?
2.
There's only 2 of them. There's only 2 3s. So that means that you're actually going to win 2 out of 36. And if you reduce 2 out of 36, it's actually 1 out of 18. Well, see where the discrepancy is? They're going to pay you 1 for 17, but your odds are actually 1 for 18. Actually, that's backwards, isn't it? You should actually play that game. I may not have written down the payoff properly then. I found this on some website, so hopefully that's right. But that's the way Vegas supposedly is supposed to work, right? Is what they're going to pay you is not quite as good as what your odds actually happen to be. Anyways, I think I made my point here. The concept I have today is odds are written as a something to something. Okay. Probability is put it as a fraction, make it a percentage. So let's try some examples here. So here's the first one. This is a poker example. What are the odds of winning this hand? Currently, I actually have a percentage. I found this app online that tells you the percentages of you winning. And this is basically 80%. So you have a percentage of 80% that you're going to win. Can we convert a percentage back to odds? Do you guys think you could pull that off?
Yeah.
You guys with me still?
Sorry.
Okay, let me do a different example here. What are the odds when you flip a coin? You would say 50-50, right? The odds on a coin are 50-50. The percentage would be 1 out of 2. Can I say that one more time here? When we say we flip a coin, we say the odds are 50-50, 50 to 50, but you'd say your percentage is 1 out of 2. So here's your percentage, 80%. Right? What is 80% as a fraction? Anybody know?
8 out of 10.
Sure, that'll work. 8 out of 10. Can I reduce 8 out of 10 at all?
Yeah.
What does it reduce to?
1 out of 2.
Not 8 out of 10.
4 out of 5.
That'll work. Okay. So 4 out of 5 means that 4 times you win out of 5 times. It's okay. Can I say that one more time here? 4 out of 5 means that you win 4 times out of a 5 total. If I want to write it as odds, here's how I write my odds. 4 times you win. Anybody have any idea what the next number needs to be?
1.
Correct. Your odds are 4 to 1. It means that 4 times you win, 1 times you lose. These two numbers right here collectively add to 5. So that's why it's 4 out of 5 as a percentage. As your odds, 4 times you win, 1 time you lose. This is where gamblers make their money then. Let's say the pot was $1,000 and you raised 20. Should you call? Well, if you've got 80% chance to win, they've got a 20% chance to win.
Do it.
Okay. Well, how do we figure out their odds? If your odds are 4 to 1, what are their odds of winning? If you are a 4 to 1 to win, what's the other person?
1 to 4.
1 to 4 is correct, yeah. Because let's do the exact same thing. 20% is 20 out of 100. It's 2 out of 10, which is 1 out of 5. So basically, they're going to win 1 time, and they're going to lose 4 times. Does that make sense? So from a gambling point of view, are they going to win very much? No. Right? They're going to win once in a while. But maybe the money's worth it. If they have to call $20, how much would they win? They would actually win $1,020. Well, in this example here, I think it's worth it. Because are you going to lose your $20? Probably. You're probably going to lose your $20, right? But on the off chance you win, you're going to win a lot of money. You're going to win more than 4 times your money, right? Here, for 1 time you lose, you win 4 times as much. If I were to reduce these numbers, 20 and 2020, does anyone have a calculator? Can someone take 1020 and divide by 20? 1020 divided by 20? 51. Basically, your odds are, you're getting paid off 1 to 51. So your odds of winning are 1 in 4, but you're getting paid $51 if you do win. This is a great deal in the long term. Does that make sense? Because let's say you played the game 5 times. I'd expect you to win once. So first time, you lose $20. Second time, you lose $20. Third time, you lose $20. Fourth time, you lose $20. So you've lost 80. Does that make sense? But the 5th time, statistically, you're going to win. And you're not going to win just $80. You're going to win 1,000 plus the 20 the other guy raises. So every time you play 4 hands, you lose 80. The 5th hand, you make $1,000. Then it's worth it. Does that make sense? That's what gamblers do. They calculate their odds of winning. They compare it to the pot odds of how much it's worth it. And that's how the gamblers actually, that's what the professionals do. Okay, so here's a slide that basically just talks about the behind the scenes math here. Odds in favor is a ratio. It's the event will occur to the event will not occur, like winning / losing. Guys, focus, please. It's like day 1 and you have no attention span again. Okay. The odds against is the event will not, and then the event will occur. So let's try some more examples. Oh, one more slide here. Probability is a fraction or it's a decimal. So if I'm asking you for probability, it's a percentage, a decimal, a fraction. Odds are like as a ratio. Sometimes you use the word 2 in there. I feel like I should talk about this notation here. This is the number of ways that A happens. Do you guys remember what that little notch there means?
Not.
Good. It's called a complement. It's the number of ways that A does not happen. Basically, either you win or you do not win. That's the 2 possibilities, right? Okay, so here's a graphic that we actually did already. This was shootout percentages. I want to figure out the odds now of Datsuk scoring. How many times did Datsuk score? Well, he scored 33 times. But it's not 33-72. Because that's not how we do odds. he scored 33 out of 72. But the odds are going to be he scored 33 times. How many did he not score?
39.
How'd you figure that out?
Minus 33 from 17.
Right. So just take your total minus the ones in which they scored. These two numbers right here, they better add to 72. 33 times he scores, 39 times he doesn't score. Those are his odds for it. Yeah, he scores almost as much as he misses. He's about a 50-50 shooter, right? Give or take. Okay, Getzlaff. Well, he scores on 21, but how many did he miss? Again, to find that number, just take this one and subtract that one. So he scores on 21, misses on 34. Nielsen scores on 25. You know what? He's actually looking pretty good. Again, we said this the time I did these notes here. I don't even know who Frans Nielsen is. Never heard him as a hockey player, but at one point he was the best shootout player in hockey because Datsuk actually misses more than he scores. Getzlaff misses more than he scores. Nielsen, whoever this guy was, actually scored more than he missed. Does that make sense? So this is how you'd write odds. Anyone want to hazard a guess as how we talk about the odds against him scoring? That's all you do, yeah. If it's odds for, it's this. If it's odds against, you put the losing, then the winning. You put the losing, then the winning odds. Now I got to make sure I'm really clear, though. He did not score on 18 out of 25. He missed on 18, scored on 25, so he was actually 25 of 43. So most kids, they struggle in this unit here just by making sure they get everything straight. Okay, so let's try a game here. I'm gonna give you gambling odds again here. Your odds of winning game 1 are 5-2. The odds against winning game 2 are 7-3. Which game should you play? So maybe the best way of doing this, odds are kind of confusing. The best way of doing odds, figure out your probability as a percentage. So in game 1, you're going to win 5 times. You're going to lose twice. How many times are you going to play total then based on this? Okay, so your probability is 5 out of 7. 71% of the time you win. That's not bad, eh? I'm liking that percentage. I shouldn't say odds, because these were the odds. That's a pretty good percentage for winning, right? But we should try the other one. But the other one's confusing. It's the odds against winning. So in game number 2, the odds against winning means the first number is the losing, and the second number is the winning one. 7 times you lose, 3 times you win. So you actually won 3 out of 10, which is 30%. So which game should you play? Without a doubt, play game number 1 because you're going to win most of the time.
You could still get this answer right because even if you did the against winning game right, like if you did like 7/10, it still equals 70%.
That's true, but 70% of the time is actually what you lose, technically, yeah. Oh, was that my last slide?
Yep.
That was my last slide. Short and awesome. Okay, so quick recap then. It's almost 3. I should give you a break. Probability is a percentage. It's a fraction. It sometimes is a decimal. Okay. Probability is the number of ways you win divided by the total. Odds are always phrased as either the number of ways you win to the number of ways you lose, or lose to win. Right? Like the way they do the Vegas odds. Going back to where we started here. 8-1 means that 8 times the Patriots will lose, 1 time they'll win. So they think the Patriots will win 1 out of 9, which is basically 11%. They think the Patriots have an 11% chance of winning. They think that Cincinnati is going to win 1 out of 21 because 20 and 1 adds to 21. So as you go further down the list, it's now 1 out of 31. Does that make sense? Normally what they'll do for odds is they'll try to make either the first number or the last number the number 1, just so that it kind of is like a 5-1, 4-1. Because having like 33 to 72 odds is kind of awkward. So I should talk about that though. If I gave you 4-2 odds, you could reduce that to 2-1. Does that make sense? Because 4 divides by 2 to give 2, and 2 divides by 2 to give 1. Let me just do one more of those, just in case that comes up. What if I gave you 30 to 100? How might that get reduced? You could divide both of them by 10. So then you could say this is like 3 to 10 odds. Can I reduce it any more than that? I don't think so. They might go like 1 to 3.3 repeated. And they might try to make one of the numbers a 1. So if you divide by 3 by, like if you divide this one by 3, 3 divided by 3 gives you 1. 10 divided by 3 gives you 3.33. They might try doing that. So I do need you to be aware that they might reduce odds. But yeah, odds and probability. Similar yet different. Sound good? Okay, go take a break. When you come back, I think there's 2 main things you should do. You should start on assignment number 6. If you haven't done number 5, do 5. If you haven't done 5, do 4. But you got to do them in order, okay? And you got to get them done as soon as you can so I can give you feedback. Well, you should have done 1, 2, and 3 already. That's the first thing. Okay, one more thought. You should also try some questions in the duotang I made you. So I just handed you a worksheet on probability and odds. Try a few of them. Right? See if you get the concept. Call me over. I'll check your work. So you got half an hour. Don't waste it. Do something productive with the next half hour.
Do you have most of the 75 or?